Have you ever pondered about the past of our universe? This isn't just a question of history, but a question of existence, of reality itself. Many of us tend to think of the universe as a static, unchanging entity, but it's far from that. The universe is dynamic, ever-evolving and full of mysteries that challenge our understanding of time and space. Just like us, the universe has a past, a present, and a future. It was born some 14 billion years ago in a spectacular event known as the Big Bang. This explosive birth set the stage for everything we see around us today, from the smallest particles to the vast cosmic structures. But unlike our past, the universe's past isn't written in books or etched in stone. It's encoded in the cosmos itself. Today, we stand at a unique point in human history where we can look back in time, decode the universe's story, and perhaps even glimpse its future. But the universe isn't a passive player in this cosmic drama. It's active, changing, and full of surprises. And one of the biggest surprises may be a concept that sounds straight out of science fiction: the universe resetting itself through a big crunch. The Big Crunch theory proposes that the universe, after expanding for billions of years, could one day start to contract. The galaxies, stars, and all matter would rush back towards a single point, culminating in a colossal implosion. And then perhaps a new Big Bang would occur, giving birth to a new universe. It's a mind-boggling concept. A universe that recycles itself, that has potentially gone through countless cycles of death and rebirth. It challenges our understanding of time, of beginnings and endings. It's a theory that pushes the boundaries of our imagination and our scientific understanding. So, as we look up at the night sky and gaze at the distant stars, we can't help but ask, is this the first time the universe has danced this cosmic dance? Or is it repeating a cycle that has played out countless times before? This leads us to wonder, could there have been a big crunch in the distant past? To unravel this mystery first, we need to comprehend the concept of a big crunch. The Big Crunch theory is a cosmological model that paints a rather dramatic picture of the universe's future and perhaps its past as well. According to this theory, there may come a time when the expansion of the universe, which has been happening since the Big Bang, will slow down, halt, and eventually reverse. Imagine a cosmic U-turn, where all the galaxies, stars, and matter currently moving away from each other start to gravitate back towards a central point. This reversal would lead to a cosmic compression, a gravitational pull so strong that it would squash everything in the universe into a singularity, a point of infinite density. This state is eerily similar to what we believe existed just before the Big Bang. Now here's where things get interesting. If the universe can crunch itself down into a singularity once, who's to say it can't explode back out in another Big Bang, effectively resetting itself? This cyclical model of the universe is known as the Big Bounce. The physics behind this concept is deeply rooted in our understanding of gravity, as explained by Einstein's theory of general relativity. The balance between the expansive force of dark energy and the compressive force of gravity is delicate. If gravity becomes the dominant force, it could pull everything back into a singularity, setting the stage for a potential big crunch. However, it's important to note that this is just one of many theories about the universe's fate. While the Big Crunch is a compelling concept, it's a model that hinges on the unknowns of dark energy and its interplay with gravity. So, if a big crunch has occurred, the universe as we know it might be a reset of a previous one. But, as with all things cosmological, it's a topic that raises more questions than it answers, a testament to the wonderfully enigmatic nature of our universe. Now that we grasp the concept of a big crunch, what evidence might suggest it has already occurred? Imagine the universe as a grand cosmic detective story with clues scattered across the vast expanse of space. We're the detectives, trying to piece together these cosmic breadcrumbs to reveal the universe's deepest secrets. One such secret might be the evidence of a past big crunch. One potential clue comes from the cosmic microwave background radiation, or cmbr. This radiation is a relic from the early universe, a snapshot of the cosmos just a few 100,000 years after the Big Bang. Tiny fluctuations in the cmbr might hint at the universe's past, and some cosmologists propose that patterns in this radiation could reflect a previous cycle of expansion and contraction. Imagine a balloon inflating and deflating. As it expands, the surface stretches, and as it contracts, the surface compresses. Similarly, the universe might bear stretch marks from its past cycles of expansion and contraction. These cosmic stretch marks could appear as patterns in the cmbr, a tantalizing hint of a past Big Crunch. Another potential clue lies in the distribution of galaxies across the universe. The galaxies are not randomly scattered. Instead, they form a vast cosmic web, with galaxies clustered along filaments of dark matter. This structure might be a fingerprint of a past Big Crunch, with the universe's cycles of expansion and contraction influencing the distribution of matter. These cosmic clues are not definitive proof of a past Big Crunch. There are many interpretations and many uncertainties, but they give us a glimpse of the grandeur and complexity of the cosmos. They remind us that the universe is not just a static backdrop, but a dynamic, evolving entity with a history as rich and mysterious as our own. So we continue to search, to question, to explore, and as we delve deeper into the cosmos, we might find more clues, more breadcrumbs leading us towards the truth. These cosmic hints might be the universe's way of whispering its deepest secrets to us. But if a Big Crunch has indeed happened, what does that mean for our understanding of the universe? This question opens a Pandora's box of fascinating implications. If our universe has previously undergone a Big Crunch, the implications are as profound as they are intriguing. Firstly, it implies a cyclical nature of the universe. Imagine it as an infinite loop, expanding and contracting over and over again. Each expansion, starting with a Big Bang, leads to a universe much like ours. Then, over trillions of years, gravity pulls everything back together, resulting in a Big Crunch. This cycle, known as the Big Bounce, could potentially have been repeating forever, making our universe just one of an infinite series of universes. Secondly, if a past Big Crunch has indeed occurred, it suggests that another may be in our future. This raises a host of questions about the destiny of our universe. Will the galaxies we see today eventually rush back together in a reverse of the Big Bang? If so, when might this happen? These are questions that scientists are still grappling with. Thirdly, a Big Crunch scenario also has profound implications for the laws of physics as we understand them. If the universe can both expand and contract, it suggests that the laws of physics may not be immutable and fixed, but rather, they can change over time. This is a radical departure from our current understanding, and would require a new approach to theoretical physics. Lastly, it's worth noting that a Big Crunch event would be a game-changer for cosmology. It would offer a new way of looking at the universe, not as a one-time event, but as a recurring phenomenon. This could open up new areas of research, and potentially revolutionize our understanding of the cosmos. The concept of a Big Crunch challenges our current understanding of the universe's timeline and destiny. It's a reminder that, in the grand scheme of things, there's still so much we don't know about the cosmos. And it's that mystery that makes the study of the universe so incredibly captivating. The universe holds many secrets, and the Big Crunch is just one of its enigmas. As we've journeyed through the cosmos together, we've delved into some of the most profound riddles of existence. We've explored the perplexing concept of the Big Crunch, the idea that our universe may undergo cyclical periods of expansion and contraction. We've pondered the tantalizing evidence that suggests a Big Crunch event may have occurred in the distant past. And we've grappled with the mind-bending implications of such an event. What would it mean for our universe to be cyclical, to have no beginning or end, but rather an endless sequence of rebirths and renewals? The Big Crunch is not just a scientific theory, it's a testament to our curiosity, our desire to understand the world around us. It's a reminder that even in the face of the incomprehensible, we refuse to be daunted. We continue to ask questions, to probe deeper, to unravel the mysteries of the universe one thread at a time. But why do we do this? Why do we strive to understand the universe, to make sense of the unfathomable? Is it simply because we are curious, or is it because we seek to find our place in the cosmos, to understand our role in this grand cosmic drama? Our pursuit of knowledge is driven by a fundamental human instinct, a need to comprehend the world around us. We seek answers not just to satisfy our curiosity, but to find meaning, to make sense of our existence. The Big Crunch theory is a shining example of this quest for understanding. It's a testament to our tenacity, our refusal to be daunted by the unknown. And as we continue to explore these cosmic mysteries, we are not just learning about the universe, we are learning about ourselves. As we continue to explore these cosmic mysteries, we inch closer to understanding our place in this vast, ever-changing universe.